Okay, here we go. We want to finish up with 4 problems and then give you guys a significant work time. There are two types of integrals. Number 1, the definite integral, and number 2, the indefinite integral. Kind of like in English, we have definite articles and we have indefinite articles. What's the difference if I talk about the apple compared to an apple? Yeah, the is suggesting that there was specifically a specific apple that we're talking about, right? Whereas this is referring, it could be just anyone, right? So what we did the other day is we said, well, we're going to look at an indefinite integral. So the antiderivative of x squared or x cubed dx, we would say is what? Thank you. That is the indefinite integral, because there are many answers you could have that you could fill in for C. Agreed? So when we're talking about the definite integral, that's where it is bounded, and you're going to come up with just one result, right? You're going to come up with whatever f of 2 minus f of 1 is. So the difference between a definite integral and an indefinite integral. So here am I working on the definite integral or an indefinite? Definite integral. We already know how to do this, don't we? So let's go. Let's practice. How are you going to do this one? Geniuses. I'm going to pull this apart into 2 fractions. Is everybody okay with that expression? Because that's all we know how to do right now, folks, is to write everything with a constant, a variable, and a power. That's really all we know how to do. So that's our option. So here we go. I got the integral from 1 to 2 of what's a 1 over x to the 1/2. How do I rewrite that? X to the negative 1/2. Great. Now I know how to take the antiderivative. Before I didn't. Now I do. Minus, what's x to the 1/3 over x to the 1/2? When you're dividing, what do you do to the exponents? You subtract, right? I mean, if I had x to the 5th over x to the 7th, wouldn't you say that that's x to the negative 2? So in the same situation, we're going to take 1/3 minus 1/2. So 1/3 minus 1/2, or 2 over 6 minus 3 over 6. And what do we get? Negative 1/6. So I have minus x to the negative 1/6 dx. You have fun. Like the mask. That's Henry. All right, antiderivative of x to the 1/2. X to the 1/2 divided by 1/2, which is the same as, 2 roots of x. Minus, and this is going to be x to the 5/6. You're going to add 1 to get 5/6. Dividing by 5/6 is the same as multiplying by 6/5. At this point, you would plug in 2. We would just write this as a decimal. There's no nice way to simplify the 6th root of 2. Can we just leave it and say Mr. Gens won't give that kind of a problem on your test? Okay, but at this point, you just plug in 2, and then you plug in 1, subtract, right? Okay, so let's do a different one. We've got the integral from -3 to -1 of 4y minus, how should I rewrite 3 over y squared? Good, 3y to the negative 2. So let's take some antiderivatives here. What's the antiderivative of 4y? 2y squared. What's the antiderivative of 3y to the negative 2? Leon sees it. He increases the exponent to negative 1. And then when he divides by negative 1, it switches the sign. So he has a plus 3 over y. If you need to convince yourself, go ahead and write it out and add 1 and divide by the new exponent. That is what you'll get. I plug in negative 1. I plug in negative 3. This one should work out quite nicely, shouldn't it? Yep. If I plug in negative 1, I get 2 minus 3 minus, what do I plug in next? Negative 3 squared is 9 times 2 is 18. Then what? Minus 1. So I have negative 1 minus 17, which is negative 18. What does that mean about the curve? It sits below the x-axis during that time, doesn't it? And so if we, in fact, check that on our calculator, that's what we should find. What do you think about letter I? Does it look scary? Does it scare you? Scares me to some degree. I don't know about you guys. Let's try it. As you notice, there are no squareds here. So I'm going to do a little trick. Integral from 0 to pi over 4. And I'm going to write it as 1 over secant plus tangent over secant. Secant is the reciprocal of cosine. Very good. Secant is the reciprocal of cosine. So 1 over secant is cosine. So you have the integral of 0 to pi over 4 of cosine of theta. That worked out well. And then tangent divided by secant. Let's see if that simplifies. Tangent divided by secant. Tangent is the same as sine of theta over cosine of theta divided by secant. Secant is 1 over cosine. So remember last year when we simplified some trigonometric expressions, you sort of do a sine, cosine, tangent, and you're multiplying, dividing. When we multiply by the reciprocal here, what happens? Yeah, the cosines cancel, so you get plus sine of theta. So it turns out that 1 plus tangent divided by secant is the same as cosine plus sine. That's kind of handy. Question? What's the antiderivative of cosine? Sine. What's the antiderivative of sine? Negative cosine. And we evaluate at pi over 4 and at 0. Who knows what the sine of pi over 4 is? Very good. Root of 2 over 2. What's the cosine of pi over 4? Also the root of 2 over 2. Look at that. Just saying, whoever made that problem up, pretty smart guy. What's the sine of 0? And what's the cosine of 0? 1. I love it that you guys know that. I know it wasn't a woman because I made up the problem. Root of 2 minus root of 2 over 2 minus root of 2 over 2 is 0. Minus negative 1. And I get 1. What do you think? Not too bad? Last example. Cotangent times sine. What would you do? I mean, what if I just rewrite them in terms of sine and cosine? What happens? Yeah, you can see the signs just go away, don't they? And so we're left with the integral from pi over 6 to pi over 3 of cosine of theta d theta. The antiderivative of cosine is sine. Evaluate at pi over 3 and at pi over 6. My good friend Lindsay, well, she knew the exact value of sine and cosine of pi over 4. She knew that that spot was the root of 2 over 2, root of 2 over 2. I just need to know these two others. 30 degrees is your pi over 6. What's that coordinate? And then this one here, the pi over 3 spot is, and so which value is sine? It's the y value. So it looks like we're going to have the root of 3 over 2 minus 1 over 2, which is the root of 3 minus 1 all over 2. Not too bad, huh? That's because you're so smart. That's all I have for you, folks. Just a little 12-minute lesson. We're going to give you guys time to work now. And the first question is on problem number 5 on your worksheet.